Okay, in this video I'm going to talk about the relation which is between one second. Okay, which is between theta, a radius of circle, radius that is represented by r, and arc length. Okay, arc length that is in book, it is represented by letter S. Okay, now where is R, where is okay, S. Okay, this is your circle, this is your center of the circle, and what is called arc? When you move on the boundary of the circle, this is arc, this is complete one arc. Suppose from here you started moving and you have complete one round and again come to this point, this is full arc. The part which is curved, that is called arc. So here this is the curved part. Okay, this is the center point of the circle. So the line segment which touch one end point at the center and one end point at the boundary is known as the radius. So this is going to be the radius, because line segment, what is called line segment? Line segment, both end points contain these dots, that is called line segment. Okay, so here every line is going to be line segment because this is a fixed distance from the center to the boundary. So it is getting limited up to the boundary, and one side getting limited to the boundary and another side it is getting limited to the center. So this part is called, this is line segment, and this line segment for the circle is known as a radius. Radius because one end point lies on the center and one end point lie on the boundary of the circle. So this is called radius. Okay, when this line move from here, start rotating, and suppose it comes over here. Okay, so this is the part. This is the part covered by the radius when this radius line is moved from this distance to this distance. So this is the distance. This okay. This is the part arc length. What is arc length? Arc length is, this is the part which is travel on the boundary of the circle. This is the part, the distance which is travel on the boundary of the circle, that is called arc. So this, if you complete one round, that is the complete one round, one arc, and if you are taking the part of that arc, that is called arc length. So this is over here is the arc length. This is arc length, and this length I am going to represent by letter S. For at this time of this point of time, this arc length is S. This is radius of the circle. So if this is R, this is also going to be the arc. R anywhere, one end point lies on the center or another point lie on the boundary, this always will be the R. So here I am going to talk about this section which is shaded by these lines, and when this line, this radius rotate from this point to this point, it rotate by angle theta. This is the angle theta over here. So what is the relation between this theta, R and S? So that relation is theta equals to arc length upon radius. Okay, theta equals to, what is arc length? Arc length I am representing over here S, and the radius of the circle is R. So this is the one relation over here which you need to memorize, and this theta is in radian. Why? Because this S unit and this R will be having some unit, like suppose this is 6 inches long and this is 2 inches long. So okay, this is 6 inches long, this is 6 inches, and this is 2 inches. Suppose for example I have taken, so this unit will cancel out inches, and this 2 also cancel out, so this become unitless. So when the theta become unitless, it is measured in the radian. Okay, so this part here is coming theta. Theta is unitless over here, that is called we have represented the theta into the radian when it is unitless. Okay, there are various ways of representing the theta, but here in this like in your syllabus we are going to talk about two forms of the theta, two representation of the theta in two forms. One is radian or one is in degree. So we see later on what is the relation between degree and radian, how the one radian could be converted into degree or degree could be converted into radian. So here we have seen the relation. This three part I have taken. One part is theta, one is radius, and one is arc length. Arc length is a part of full arc. Okay, radius this line, and when this radius moves from one point to another part, so the region covered by the radius make an angle at the center. So this angle is called center angle, the angle made at the center. So this angle is represented by the theta. So what is the relation between this theta, s and r? This is the relation, theta equals to arc length upon radius. Arc length I am representing by letter s, so I have replaced over here this arc length s, and this radius is r. Here are very application part of this, like suppose the question is given like this is a circle. Find the center angle when the radius of the circle is 2 feet and the arc length is 12 feet. Suppose this distance traveled by the on the arc length is given 12 feet. So I need to calculate this theta. What are the terms are given? R is given 2 feet and s is given, arc length is given 12 feet. I need to calculate theta, so I apply the formula theta equals to s upon r, and s is given 12 feet, and this is given 2 feet. Feet also cancel out, and this also cancel out, so 6. So the theta has come 6 unit, correct, 6, and this is unitless, so this is theta representation in radian. Okay, so this how we have seen the relation, and this relation you need to memorize, the relation between theta, s and r. Theta equals to arc length upon radius, and on this like out of these three any two quantity will be giving and one quantity you need to calculate. So we see more example on this and how the question could be developed on this pattern and how it could be solved. Thank you.